Okay, so the next problem on the review, I change the exposure for this, um, is, sorry about that, is going to be 5.10. So the problem reads, the pH level, a measure of acidity, is important in studies of acid rain. For a certain lake, baseline measurements of acidity are made so that any changes caused by acid rain can be noted. The pH for water samples from the lake is a random variable x with probability density function PDF given by this. So we want to, in this problem, find the cumulative distribution function CDF f of x of 4x. So the problem says just distribution function, but sometimes people shorthand the CDF or cumulative distribution function just as the distribution function. I prefer to not do that, but anyways. So to find the distribution function, we really want to think of this in three cases, right? Because what is our cumulative distribution function f of x? This is going to be equal to the probability, just by definition, that our random variable x is less than or equal to little x. So the first case that we need to consider is going to be if x for x that is less than 5. Because in this case, what do we have? We have the probability that x is less than or equal to x. If x is less than 5, then we have, right, all of our PDF is going to be between 5 and 7. We have no non-zero PDF that's less than 5. So this is going to always be 0 in this case, because this is the probability that we're less than or equal to 5, but we only have non-zero PDF greater than or equal to 5. So this, if we integrated, we're integrating over 0. This is going to become 0. So the second case that we need to do is we need to think about what if x is between. So maybe let's do the last case first. So the second case we can think of is if x is greater than 7, right? So let's do that. So for x greater than 7, so now I'm saying what's the probability that x is less than or equal to some x that's greater than 7? But if I'm greater than 7, that means that all of my distribution, my probability density function, is going to be to the left of me, is going to be less than or equal to me. So that means like whatever this distribution looks like between 5 and 7, right? It's going to be something. The probability that I'm less than or equal to this, I'm going to be integrating over all my non-zero PDF. That has to be equal to 1. So in this case, my f of x is going to be equal to 1. So the last case, which is really the only case that we have to kind of calculate out a little bit, case 3 is going to be when I'm between 5 and 7. So in this case, what am I going to have? I'm going to have that the PDF, right? Sorry, the CDF of little x. Remember, this is the probability that x is less than or equal to little x. So this is equal to, I'm integrating now from negative infinity to x, my density function. Right, if I'm calculating a probability, I integrate the density function over that whatever range that is. This range is going to be what? It's going to be all the x values that are less than or equal to little x. So that means all the way from negative infinity to x. And then this is going to be dx. So in our case, again, we're only going to have non-zero values for the PDF, right, when we're between 5 and 7. So in our case, I know you can't see it anymore, but that's okay. I'll write it down. We're going to be integrating only between 5 and x. And now our probability density function is going to be 3/8 7 minus x squared. And then this is dx. So I want to integrate this. Right, so because this inside is not very complicated, I could do this one. Remember I said that you can kind of do the u subs by kind of guessing and checking, blah, blah, blah. You could FOIL this out and do it if you wanted. I think that we can do this as follows. I think this is going to be equal to, so we pull the 3/8 out, right? That's out. And now when we're integrating this, if you think about this, the chain rule in general, right? If I was taking the derivative of something like this, right, I would bring this down, then multiply by the derivative inside. So now let's think of, let's add 1 here. So 7 minus x, adding 1, 3, and we're dividing by the new power of 3. So now when we take the derivative, this 3 will come down. But when we take the derivative, right, we're going to have to multiply by the derivative inside, which is going to be -1. So we're really going to need a negative in here when we take this integral. So that's kind of the guess and check u sub approach without actually doing u sub. Right. So hopefully that's right. You can take the derivative of this, make sure you get here. But I think that that should work. So now we're integrating from 5 to x. Sorry, we're evaluating from 5 to x. So maybe let's come up here. Right. So now we plug in the top number. Okay, we have a bit of an issue here. Sorry, this should be a t. I can't integrate with respect to x. These should all be t's. Sorry about that. Yeah, that's my bad. So yeah, those should all be t's. When I'm integrating, this variable has to be different than the one that's in my bounds. So I apologize for that. But this is going to be equal to 3/8. Now we want to plug in the top number, evaluate plugging in the top number, and subtract off plugging in the bottom number. So this is minus 7 minus x cubed over 3. And this is going to be minus 7 minus 5 cubed over 3. So let's see what we get. So this is 3/8. I'll leave this alone. So this is minus 7 minus x cubed over 3. And now this is going to be plus now, right, when I distribute that. And this is going to be 2 cubed, which is 8/3. So now I can distribute this 3/8. On the first term, when I distribute it in, this 3 is going to cancel. So I'm going to get minus 7 minus x cubed over 8. And then when I distribute to the second one, this 8 is going to cancel and the 3 is going to cancel. So I'm going to get plus 1. So that should be my CDF, right? So if I want to write it in one piecewise definition, f of x, so it's going to be equal to 0 when x is less than 5. It's going to, if I switch these two around, it's going to be equal to 1 minus 7 minus x cubed over 8. And this is when x is between 5 and 7. And then lastly, it's going to be equal to 1 when x is greater than 7. So that is our CDF. Right.